Warning, warning, your instructor may get a little bit more excited in this nugget than in other nuggets. And for some of you, you're probably thinking, how could I be any more excited than I already am? Well, look, we're going to talk about virtualizing servers, an exciting area for me, not just because I'm a VMware certified professional, but because I've been really fascinated with server virtualization for over a decade. In this nugget, we're going to see what the rage is when it comes to server virtualization in data centers today. In this nugget, we're really going to be centering around two main areas. We're going to be taking a look at the benefits of virtualization, and then we'll also discuss specific solutions. Obviously, one of those specific solutions we're going to look at is VMware. Before the virtualization rage in the data center, we had something that we like to call server sprawl that would take place. And it went something like this. The IT organization would say, you know what, we absolutely need SQL Server. And the organization would tell your IT department that, right? So SQL Server would be acquired and installed in an operating system, let's say Windows Server, and this would be placed on a physical box. And then, of course, Exchange is needed for email. And that would be placed on a different Win server and installed on a physical box. Why the separation? Well, organizations quickly realized that if you separate Exchange and SQL Server on two separate physical boxes, it's going to do wonders for those devices, for those applications when it comes to resource utilization and scalability. Exchange can grow and grow and grow, and so can SQL Server. Also, if there is some instabilities in either of these applications, they will be segregated from each other, and this just continued. SharePoint would get its own box, and then they'd need to do some Oracle work, and it would get its own box, maybe its own operating system like a Linux-based operating system, and the servers would just continue to sprawl. Obviously, you see what's happening here. This is going to be a real maintenance concern, all these separate boxes. This is going to be a real concern for cooling and power consumption. So this was the world before virtualization, and virtualization really took this world and turned it upside down, as we'll see. So here is what's so exciting today. What if we take a very small but very powerful rack mount server? Just as an example, there's other server form factors we could use, but let's just say we got a C series rack mount server from Cisco. What we can do in this device is we can put a bunch of CPUs. We can put a lot of RAM. We can put like 4 network interface cards. And in this particular device, we have all this high powered equipment. And then what we do is we put a virtualization software layer in. This is a very, very small image, right? It doesn't take up a lot of space. There is in the security world what we call a small attack surface on this particular operating system. only using about 25% of what that machine could do. Maybe on the Exchange server, only 40%. On your SharePoint server, you're only using 10% of what that server can do. So we really have this wonderful, efficient utilization of the resources when we virtualize. We will, in a few moments in this particular nugget, go through the amazing advantages of virtualization, and I'll only do some of them with you. We could dedicate an entire 20-minute nugget to just talking about the advantages of this new server virtualization world. So the term that I'm sure you've heard is virtual machine. That is how we refer to this virtualized application and operating system. And remember, as far as CPU, a network interface card, disk space, RAM, as far as those physical resources go that obviously an operating system is going to need, they are accessed through that virtualization layer from the actual hardware. And this brings up something that we can do that's so exciting. We can go ahead and proportion the actual physical resources to the VMs. So if we find one of our virtual machines is getting a little bit more power hungry when it comes to RAM than another one, we can go ahead and take the resource pools that we're giving these various virtual machines and tweak those and alter them so that the machines are getting that perfect amount of resources in order for them to do their job. So let's zero in on those benefits of virtualization as I promised. And the first one is that partitioning. It's that allowing a single physical box, a single physical host, as we refer to it in server virtualization, to serve all of those different virtual machines. This really brings that benefit to light about efficient utilization of that host. We don't underutilize that host, and we can appropriately assign sufficient resources to each and every VM that we design. By the way, it's really fascinating how virtual machines, how the operating systems can very efficiently utilize those resources. I remember my first VMware class, and I remember seeing Windows XP virtualized, and I was running a bunch of apps inside of that XP virtual machine, and the instructor asked me how much RAM I thought that virtual machine had been appropriated. Well, sure enough, I thought it was 4 gigabits of RAM, and sure enough, it turned out to be literally like 758 megabits that were assigned to that particular virtual machine. It was remarkable. It was the absolute bare minimum you would ever imagine, and the machine was functioning perfectly. So it's really amazing the efficiency that we get here with the acquisition of the hardware through the virtualization layer. Something else that's a huge benefit with virtualization is encapsulation. What we mean by this is the virtual machine is really just a set of files. That's right. Everything is defined in a set of files. So this means that the virtual machine, everything associated with it, can easily be backed up, can easily be modified through manipulation of the files directly if we need to. It can easily be duplicated, that virtual machine, because it is just that set of files that really makes all this magic happen. And we have that other huge benefit that we already alluded to of isolation, right? We loved the fact that SQL Server might be completely isolated from Exchange in our data center, and we can still have that isolation even though they are running over the same physical host. Hardware abstraction refers to the fact that we can really easily take VMs and move them between hosts. So this is an amazing feature, and we see this with something called vMotion in a pure VMware type environment. So you are running a VM on this box, and this box needs some maintenance. So you very easily migrate that particular virtual machine to another host. You do the maintenance that you need to do on the original host, and then you migrate that virtual machine back. So there is great abstraction between the VM and where it really lives. And this can help us optimize performance by moving a VM maybe for resource reasons. It can help us with maintenance, as I described, and it can even help us with resource optimization. So if the resource usage of one or more of our VMs has decreased, we might have one or more hosts that might not be needed. So we can take VMs and redistribute them and then literally power off a particular host to save on both cooling and power in the data center. Keep in mind that this is going to have the benefit to our IT organization of reducing our capital expenses. Sure, we're going to need to buy fewer physical servers. And from an operating expense perspective, we're going to need less cooling, we're going to need less power, we're going to have common drivers, so our overall environment is going to be more stable and cost us less operating expenses. So now I think you really understand, and this is just a small look at it, you really understand why virtualization of servers has become the norm in today's data center environments. Now, there are indeed different manners in which the virtualization can be pulled off when you look behind the scenes at what's actually going on. Most of us are excited about full virtualization. This is a complete and total guest OS for a para-virtualization type of environment. Now, as promised, let's elaborate on that host OS based virtualization for a moment. Notice we have an additional layer here. We have a host operating system. So here's our bare metal server, but then we have to install on top of that an operating system like Windows. Then we install the virtualization software on top of that. Then we can do our fancy operating system and app thing, and they can live side by side with all the separation and all the benefits that we discussed. Ew, this operating system layer, that's going to be a potential problem, right? That's consuming resources from the bare metal server. It's making a nice big attack surface for security concerns. I mean, think about it. The operating system could have huge vulnerabilities in it, and that makes this whole thing vulnerable. What's an example of a host OS based virtualization approach? Well, let me show you. Here we have VMware's Workstation product. This is what VMware would call a Type 2 virtualization engine. Type 2 means it's host OS based. That's right. I am demonstrating this to you on a Win 7 machine. So I have Win 7 installed on a traditional tower machine. And then on top of that, we install this VMware Workstation product. Now we can create virtual machines on top of that or in the scope of that application. So notice the Windows 7 operating system here makes this a Type 2 host OS based virtualization product. By the way, creating a new machine is literally, a new virtual machine is literally as easy as stepping through a wizard. Saying, yeah, I'm going to create a new virtual machine. I have an installation disk and this is a great platform to do testing, and maybe if I'm on a Windows box and I want to run some flavor of Unix, this would be a great solution for that, right? Yeah, so if I want to run Unix inside of my Win 7, this would be a nice, easy way to do that. We call this the virtualization of desktops. But inside the data center, what we're excited about is what VMware calls Type 1 virtualization, and that is bare metal virtualization. That is taking a server, not running a traditional OS on it, but instead running VMware's hypervisor in a VMware solution example, and then running our operating systems on top of that. The hypervisor is called ESXi that VMware has standardized upon. You see, back in the old days, VMware had an ESX operating system that you would install as your hypervisor. This was bigger and bulkier than ESXi. I stands for embedded or integrated, I believe, right? Embedded would be funny. ESX, one of the reasons that VMware dropped development of that product was the fact that it was based on a Linux kernel. So this was much too much like doing OS host based, right? Yeah. This was having Linux there, even though Linux is beautifully efficient, that was still too much like needing an operating system. And that's why VMware has standardized now and is continuing to develop ESXi, which eliminates that requirement for the Linux kernel. So bare metal becomes the rage. In VMware terms, this is ESXi providing that hypervisor for our bare metal server. Wide variety of vendors we could go with there, including now Cisco themselves, who are in the server market. And then, of course, our operating systems and their applications riding on top of that hypervisor. Now, when you speak of VMware's solution, VMware offers you a product called vSphere. And right now it's vSphere 5.x. Inside this umbrella of software, okay? In fact, you would really call this a software suite. Inside of this software suite, you get the ESXi. You get something called vSphere Server. As you might guess, this is for managing the hosts in your environment. You get a vSphere client, a way in which from a manager's desktop to make a connection and manage this environment. You get things like VMware's View product. The View product is a way in which that you can manage the virtualization of desktop operating systems for all of the clients that are wanting to access the information inside of your data center. Realize the power of this. The back end applications like SQL and SharePoint, they're virtualized. And then utilizing a product like VMware's View, we can easily push out virtualized desktops to the machines out there in your environment that are going to want to access the information that's in the data center. So vSphere is that suite of products, a wide variety of products in that suite to really enhance the server virtualization experience. And of course, VMware is not the only game in town. Let's take a look at Microsoft's Hyper-V. It's a hypervisor-based server virtualization product. Aha, so in VMware terms, this is a type 1. It's a bare metal implementation. It's not a host OS-based implementation. Hyper-V is a dedicated standalone product that contains the hypervisor. Server operating system. This sounds like it would be a negative, but then Microsoft says, as a result, Hyper-V server produces a small footprint and requires minimal overhead. Interesting. So for a virtualized data center environment where we're just interested in running something like Exchange virtually as efficiently as possible, Hyper-V might be the solution that we go with. And it wouldn't be fair of us not to mention another big player in the space, and that's Citrix. Notice Citrix offers a Xen Server implementation, and Xen Server is going to focus on virtualization. On a bunch of different operating systems, that's when we have to turn to a solution like VMware or Citrix. So I hope you had as much fun as I did in this nugget where we took a look at the wonderful world of server virtualization, focusing on both the benefits and the specific solutions that are out there that we can take advantage of. I certainly hope this has been informative for you, and I'd like to thank you for viewing.